Hi again, everybody. In this lesson we're going to be calculating the mechanical advantages of wheels and axles. In order to calculate the mechanical advantage of a wheel, first of all you need some information. The wheel and axle both have properties. You have a diameter and an amount of force on the wheel, and that will be one of your force moments. And then you have the force and diameter of the axle. That'll be the other force moment. One of them will be the force of effort, the other will be the force of resistance. You can see up here the formula that we use is the same formula we used for levers. So it's just figuring out which measurements and which amounts go to which part of the problem. So in this problem we have a solid wheel and a solid shaft axle, and we can see the direction of the spin of the axle. We see that the axle has 40 foot-pounds applied to it, and we see that the diameter of the axle is 3 inches because the arrow right here is pointing at the middle. We can also see that the diameter of the entire wheel is 18 inches. So the only thing we're missing is, in order to be able to complete this equation, is the diameter of, or the amount of force that is on the wheel. We know how much force is on the axle, but not on the wheel. So when we do this, what we got to do is we got to set it up so that we know the numbers in the equation. So let's call the force on the wheel the force of effort, and the force on the axle the force of resistance. So we have F of E times 18 inches, the force of effort on the wheel, times the diameter of the wheel, equals 40 foot-pounds of force on the axle times the 3-inch diameter of the axle. So that's how you calculate, or you set up your equation. So there's your formula, there's your plugging in your numbers, and now we'll chug through the problem and we'll see what happens next. You take both of those and you divide them by the number that is next to the variable. The variable is F of E, or the unknown. The unknown is F of E. So in order to be able to calculate that, you're going to have to divide both sides of your equation by 1.5. So you can separate the unknown from a known. Dividing 1.5 from both sides of the equation will allow you to get F of E by itself and give you 40 foot-pounds times 25 feet, or 0.25 feet, divided by 1.5 feet. Now let's take a quick look at this while we're thinking about it. We needed to convert inches into pounds because the unit of torque in this case is foot-pounds, and the unit of length in the diameters is in inches. So you can't have an equation that has feet and inches. You have to either convert the feet to inches or the inches into feet. So you have all one unit. So I chose to convert 18 inches into 1.5 feet and 3 inches into 0.25 feet. Because, 3 will go into 12 4 times. So in order now that I've done that, I can divide both sides of the equation by 1.5. And when I plug in the numbers in the calculator, I get F of E in this case is 1.66, and that should be foot-pounds. Because I factor out feet from both sides of the equation, I should be ending up with foot-pounds. So I need to type that in. And that's the answer to our equation. So then you can calculate IMA, AMA, and efficiency because you have all 4 components of F of E times D of E equals F of R times D of R. I hope you're able to understand this. Please ask me questions if you need to. Send me an email or whatever. And good luck in the rest of the solutions.